Okay, so I think most of the people are already connected. So let's start with this microlearning. As I told you, I'm Carlos Martinez, responsible for the training department here in SODECA, and with my colleague Gonzalo Villa, that is going to be the responsible for this microlearning. As you know, microlearning is a program within SODECA, very specific trainings in half an hour regarding the new topics in the ventilation systems. And today we are talking about ventilation solutions for the treatment of smoke, grease, and odors in industrial kitchens. I think it's a really interesting topic regarding even the solutions we are presenting. For improve the indoor air quality, reduce the risk of fire, and to take care of the emissions to the atmosphere. So, as always, we are sharing with you the PDF of the presentation at the end of the session, so you can download it. And as always, we will have a Q&A time. So every question you have during the presentation, you can directly write it down in the tab you have in the panel control, okay, the tab for the questions, and we are answering at the end of the presentation, okay. So that's all from my part. Gonzalo, the floor is yours. You can put on the presentation mode and start with the presentation. Thank you so much.
Thanks, Carlos. Thanks for your introduction. Welcome, everybody, to this microlearning. As Carlos has said, my name is Gonzalo Villa, and I work in the sales engineering SODECA department, also where I am the filtration specialist. And welcome, everybody, to this microlearning. Ventilation solutions for the treatment of smoke, grease, and odors in industrial kitchens. There are three main reasons that support the needs of ventilation in professional kitchen. First reason is the exposure of chefs and professional people working in kitchens to the presence of PM 2.5, as you know, particulate matter of 2.5 micrometers. According to a research carried out by ASRAE, in which it was measured particle concentration in professional kitchen, they found out that according to the threshold of 25 micrograms per meter cubic uh, suggested by World Health Organization, kitchen areas were with a particle concentration higher of this threshold in more than 50% of time, which means that half part of the time of cooking they spend it in ambient with high particle concentration. They also found out that with a proper ventilation, this particle concentration could be decreased, introducing new fresh air, particle free, and replacing the existing air. Second reason that support ventilation needs in kitchen is the risk of fire. These news that I have presented in these slides are quite frequent. They usually happen in restaurant. And why that happen? You know, in kitchen there's a combination of a combination of how do you say possibilities, yes,
Three
that
factors. Three factors.
yes, three factors, thanks Carlos, three factors that can, when they combine, they can produce a fire. First factor is the presence of ignition sources with the grease accumulation in kitchen hood and ducts. You know, also in kitchens it's quite common to use flammable load such as oils, which they are used to cook, or maybe electrical equipment that if they miss work, they can cause a spark. And with those flammable materials and the accumulation of grease, they can lead to fire. Also, there are some restaurants that they do not are well designed, and maybe they don't have isolation ducts, or they haven't been properly compartmentalized. So in case of fire, it will spread easily through all the restaurant. So it's important to ventilate to remove these particles, and also to, in case of fire, give some time to the firefighters to enter in the restaurant and to fight the fire, to put out the fire with the lowest risk to the people. Third reason that justify the presence of ventilation present in kitchen is the atmospheric emissions. This new that I have presented here is quite common in Spain and also in every place where a dark kitchen or ghost kitchen is placed next to neighborhood areas and residential areas. Each city might have their own threshold values for pollutants, but it's important that in each city, in each case, these particles will be exhausted through the kitchen hood or even the kitchen general ventilation. And it's important that if you don't want to cause not harmful, because they are not really harmful effects, but disgusting effects to your neighbors, you should in any way uh, exhaust this air far from neighborhood areas, or maybe filtrate the air to make sure that you remove all the particles before exhausting them near to residential areas and where neighborhood people might live. So now that we have explained three main reasons to justify ventilation, we are going to take a brief look to some legislation that support this and that explain how to ventilate in kitchen areas. First legislation is ASRAE 62.1 regarding ventilation and unacceptable indoor air quality. In this table, as you can see, it shows that for air supply in kitchen areas, we must consider two different parameters. First, a parameter considering people capacity of the kitchen, and we shall introduce airflow rate according to the number of people in the restaurant, and a second parameter according to the total surface of the restaurant. So we might supply this total air. Also, maybe the most important legislation in this case is UNE 1165 about air conditioning, fume extraction, and ventilation for kitchen, which marks a lot of various uh, aspects to kitchen ventilation. First of all, it said as an important matter that fire units should be fire that fan units should be fire rated. In this case, F400, that means that a fan can work in a temperature of 400 degrees for at least 19 minutes. This is important because, as I previously mentioned, in case of fire, fans should work and should exhaust kitchen smoke, fire smoke, to make sure that they let people escape, and also that they do not finish the oxygen in the kitchen. This legislation also set various methods to calculate airflow rates in kitchen hoods. This first method, according to the minimum airflow, sets that the airspeed through the kitchen hood should be at least 0.25 meters per second. And in this calculation, we have to take care about kitchen hood perimeter, how many height there is from the kitchen cooking area to the kitchen hood, and also the number of open sides. We later, at the end of the microlearning, we will see a practical case in which we can see how the change of these parameters can affect to the calculation of minimum airflow. A second method, maybe more simple one, in case of absence of information about heat transfer of cooking equipment, we can calculate airflow considering just total surface of the kitchen hood and a parameter considering fuel type. In case of gas kitchen, we have to ventilate and put more airflow due to the presence of combustion particles. As you know, in gas kitchen, we might use some gas, we burn it, and then we use this energy to cook. So these subproducts of combustion should be exhausted, and that's the reason that gas kitchen might have a, a higher value considered to electric kitchen, where in which we only use electricity to heat and cook the food. This regulation also established the two parameters regarding kitchen hoods. First of all, it says that the kitchen hood shall be located at a maximum height considering the floor of 2 meters, and all the sides of the kitchen hood shall extend at least 15 centimeters in each side of the cooking area. That is to make sure that all the air from the kitchen area and the kitchen and the fire and the fuel type, yes, is exhausted through the kitchen hood. Also, this UNE 1165 sets another general aspects ventilations for kitchen, not only the kitchen hood. It says that in order to dilute odors produced in the preparation area, we have to ventilate with a minimum fresh air supply of 10 liters per square uh, per, 10 liters per square meter and per second. And also said that the kitchen shall be maintained under negative pressure considering the other areas of the restaurant, such as warehouse or dining area where people might be eating, to prevent the transfer of odors. We want to make sure that all the air goes through the kitchen hood and is exhausted from in the kitchen without leaving it. And it recommends that to maintain this negative pressure, a maximum value of 5 pascals, considering surrounding areas. Another regulation and last regulation that we are going to speak about in this case is UNE 16282 that includes and add more parameters to consider in these cases. It repeats the importance of negative pressure to maintain and prevent cooking odors to escape, but they also introduce the importance and the necessity of filter air supply, so we make sure that we are not exhausting kitchen particles, but we are introducing outdoor particles. They want to have it's important to have particle-free air supply, and that exhaust air must not exceed supply air more than 10%. So we make sure we only have a slightly under negative pressure, not a high value of this negative pressure. Regarding the third problem that I mentioned in the previous slides, the pollutant emission and atmospheric emission, to fight this problem, we will need some filtration stages, because all air exhaust from kitchen hood will have particles from cooking areas. And I'm going to speak about the two most important technologies to clean the air from kitchen hood. First one is electrostatic filtration to retain particles in the airflow rate. This electrostatic filter might have some different parts, beginning with general a general filter, and after this, it will pass the air through a ionizing cell. In the ionizing cell, particles will be charged with positive charge in the electric field of this part, and after that, once they have been charged, they will pass through the collecting cell, which is a part with negative charges, and due to the opposite of the charge between these particles, all the particles will drop to the lowest part of the collecting cells, and they will be collected, leaving the airflow clean. This electrostatic filtration is quite used in these technologies because as grease particles can be easily charged, they are particularly efficient for these particles. This electrostatic filtration also have different benefits that I'm going to mention. First of all, if we compare this electrostatic filtration with mechanical filters, we are going to find out that this technology, electrostatic filtration, will decrease into half the pressure drops over time, because As mechanical filters might get clogged as they retain particles, this electrostatic filter might retain these particles and they can be drained through a draining pipe. So it won't increase pressure drops over time. It will remain clean and it will remain free for particle and for airflow rate. This, this leads to a reduced electric consumption because if we do not need to increase the fan power due to the pressure drops, we will remain and we will maintain a constant working point for the fan. Also, as it's important because you have to maintain these filters by cleaning, you don't need to replace them as mechanical filters once they clog. You need to replace the old one with a new one. In this case, you just clean it. You have to make maintenance, obviously, but maintenance costs are lower. And second, filtration for gas exhausted from kitchen hood is gas filtration. In this case, if with electrostatic filtration we retain particles, with this gas filtration we want to retain molecules that cause odors. In this case, through an adsorption process, which is a process in which a porous material can retain small particles, small molecules uh, between their internal structure, as you can see in the picture below. This process tends to be a reversible process that occurs to the action of physico-chemical force. And most use activated adsorbent filter used is with activated carbon, which is important due to the high specific surface area that helps these gases to be retained in a small quantity of carbon. With all of this that I have mentioned, if we take care and if we join all the things that I have mentioned, the importance of ventilation, fire rated unit, and filtration, I'm going to describe our new fire rated ecology units with electrostatic filtration. This SODECA new product, it's a unique, a only unit, not modular construction. You have in a single unit with a fire rated certification all these states of filtration, and you can use this unit in case of fire. These new ecology units help to reduce the pollution exhausted thanks to both of these states, filtration, electrostatic filtration and carbon filtration. And thanks to these technologies, maintenance costs are lower. Also, thanks to the fire rated certification F400, you can make sure that in case of fire, this unit is going to exhaust air and is going to remove smoke fire at least 2 hours, which is their certification, to make sure that the people working there is going to, they can escape easily, safer, and for firefighters that they can enter and put out the fire with the lowest risk. Also, their technology of electrostatic filtration that removes particles and greases will help that in case of fire, there is no accumulation of grease in ducts, making sure that fire will not spread easily through all the restaurant. These are the new ecology units fire rated with electrostatic filtration, CGTXR FA and CGBDT ALS. Let's mention that now it's only available first one, but soon it will be available CGBDT, else FA. In this table, you can see all properties and all characteristics of each equipment. I'm not going to describe all of them as Carlos is going to later upload this PDF so you can see each property and each characteristic slowly, but I want to mention and remark some things. Both of them are certified 402 degrees, fan, box, and filters all together, not just the fan. All the unit together has been certified as fire rated unit. All of them have the same filtration states, at least G2 plus FA, but you can also add the active carbon as an optional filtration stage. And Maybe one of the difference of them is the airflow design for each one. CGBDT is designed for a smaller kitchen with a maximum airflow rate of 8,225 cubic meters per hour, which will be a normal value for small kitchens. But if you have a professional big kitchen with a high need of air exhaust, you will use CGTXR, which with one single unit, you can go up to 27,000 cubic meters per hour. So you can make sure that you can filtrate and exhaust kitchen air with one single unit. All these SODECA fire-rated units can include an external control box to help installation and make sure that working point is properly selected. This external control box will help you to make a control of temperature in airflow rate and dirty filter control. It makes you the equipment compatible with Modbus. So if you want to centralize the working point to know in a single computer unit, you can control it. And also it helps you to make a time programming in case of you need to switch on and switch off the equipment. This is normally not used, but in case of you have just small times of use, you can use it. And also that you can control and automatize the working point of the ecology unit using pollution sensors. So you make sure that you will exhaust always the right according to the needs. Last of all, I would like to remark that some legislation that I've mentioned, it says that humidity and temperature control shall be made in kitchen areas because due to this high temperature, it's important to reduce the heat in the kitchen. And as you know, SODECA, Deca Clima is a company part of the SODECA group, experts in this temperature control and kitchen climate control solution. In climate control solution, so you could reduce the heat and prepare a conditioning in the air with units such as evaporative air cooler that will reduce the heat in the kitchen, or even air-handed units that could be placed in case of need. And last of all, as I promised at the beginning, I'm going to make a practical case with our tool, which is QuickFan, and we are going to calculate easily and how do we know the kitchen air flow rate need in a kitchen hood. So I'm going to go through to QuickFan. As you can see, this would be the general introduction aspect. And if we go to this part of tools, we can go to these kitchen hoods according to UNE, which is the legislation that I mentioned previously. In this case, it's quite easy. You have to introduce the dimension of the kitchen hood. For example, 2 meters of length, a depth of 1 meter, and a height from cooking preparation to kitchen hood of 1 meter. As you can see, now there is this first value that has changed. If we move from gas to electric stove, you will see the thermal flow rate varies. We are going to consider a gas stove and the number of open faces. That means the faces that from the kitchen hood are not placed next to a wall. In this case, if we consider 3, we would see that the minimum airflow rate, that is the airflow rate that we have to make sure according to UNE, would be 3,600. A fast example, if you increase the open faces, you will increase the need of flow rate because the air can escape through more different areas. So if we go to selection, system will go to ventilation units. If we want this CGTXR, we have to place filtration units. So we place filter units with F400 certification. And if we consider 200 pascals of pressure drop, our QuickFan will show you which is the most appropriate unit. We have this CGT-XR without filtration states, just in case you just want the kitchen exhaust, and we have different models with electrostatic filtration and active carbon filtration, or just electrostatic without carbon filtration. If we go to this equipment, we will see all the general information that I mentioned previously, curve and acoustic, where you can see which value, if you are close to the pressure point, service point, and design point. And if you need, you can create the report with this technical information and all the accessories in case you need. You could, well, there are no here. The box kitchen, the external control box is selected as box kitchen. You could ask there to us. And that's all. Thank you all for your presence, for attending this micro learning. As you know, SODECA has many experience in this sector. So, in case you have a kitchen project or any type of project that you think you would need help, do not hesitate to contact us, because we can help you with this process selection. Uh, do not forget to follow us on LinkedIn, so you stay tuned in case of further micro learnings or further updates of our company. Thank you all for your attention. And Carlos, I don't know if there might be some doubts that we can clarify now that I have ended.
Thank you. Thank you so much, Gonzalo, for the nice presentation. Let's allow Gonzalo to take a sip of water if he want.
Yes.
In the meanwhile, you can write down all the questions you have. Maybe you are thinking that just half an hour is very little time to go deep in all these topics, but that's the spirit of the micro learning. Okay, super concentrate technical training, and in case you want to apply the information, we are more than happy to help you. Okay, so it's now time for the question and answer time. Let me briefly, very quickly, to share with you the presentation, the PDF of the presentation. Okay, so you can download it. Meanwhile, we are answering the questions, and then we are starting with the Q&A time in just half a minute. Okay. I think everybody can see now the document to download it. If not, you can always ask for the document to me or to Gonzalo, that you have the contact information just there. Okay, so Gonzalo, I think we have some questions. Okay,
Okay.
I am just starting with them. Um, uh, we have a very interesting question from an assistant, that is, since the kitchen should be in negative pressure, what
Yes.
is the usual rate of fresh air versus exhaust? 80%? It's a very good question.
According to UNE, I think it's 16,282.
Yeah,
You should consider 90%
at a minimum. Okay,
at a
so
minimum. Yes.
80% cool works, but you need to compensate the airflow, the minimum airflow you need to make sure that you are compensating the air you are extracting through the hood. So minimum 90%, 80% cool works, but we have a minimum of 90% that probably led to obtain this the pressure of 5 pascals that the legislation is talking about it. Okay. We have another question. Thank you for your presentation. The operation curves of the various models in QuickFan already take into account the pressure drop of the added filters?
Yes. Yes, they do. If you, I don't know, Carlos, if we have time, that maybe I could compare a show in QuickFan.
Yeah, totally. We have time. We
I
are in
think
the
I
question
think
and
that
answer
is
time.
really.
So so
If you return to this and then you change to the unit without
without the filters.
without the filter. And you can see, because I'm going to also uh, I'm going to select the three of them:
Mhm.
the color unit without fire rated unit without filters, only the electrostatic filter, and active carbon filter. If we compare them, you can see each one of them. So you don't need to add extended calculations about, okay, I have to consider the pressure drop. No, you don't have to worry about that. As you can see, with first unit is just the fan fire rated fan without filters. It's the biggest one. Number three is just electrostatic filter. And if you add the electrostatic plus the carbon filter, you will have this curve. So you make sure that once, if the curve here is selected, you don't have to add external pressure drops.
Yeah, the dynamic pressure is already
It's already,
in
yes.
our OF equipment normally included in the curve. And as you can see, the pressure drops generated by the electrostatic filtration is not as big as we can imagine because of the that's a very good quality of this type of filters. You don't need to take into account bigger pressure drops as in mechanical filters. Okay. Okay, we have more questions. We have another that is, according to standards, the kitchen must be air conditioned or only ventilated.
Uh, you know what happened? You have to air condition it if the if the give me a second. If the you have to air condition it if ventilation is not enough. But according to, you have to regulate. You cannot increase, I think it's 30% of relative humidity, and temperature should be decreased, should be below 26 degrees. So with just ventilation you cannot achieve these values. So you have to select, and that's the reason that I mentioned this evaporative air cooler from Deca Clima, because you will need extra help, because in kitchen areas temperature are so high due to fires. You are cooking, you have the kitchen, the oven turned on, you have the lights, the fires, so
Mhm.
there are so much hot that should be air conditioned.
If may I, it will depend on the parameters you need to the set point you have in your kitchens, okay, and the size of the kitchen, the size of the hoods you have. So most of the time you will need to condition the air, but could be that only with the action of the extraction fan you reach normal temperatures or affordable temperatures, okay? But most of the time, as Gonzalo said, will be necessary the air conditioning for sure. Gonzalo, we have more questions, so we continue with them,
Yes,
okay?
of course.
Uh, Hello, Gonzalo. Can you please confirm if these units are designed to be installed outdoors without any restrictions, or are there any limitation we should be aware of?
They are designed for outdoor installation, I think. Maybe I could we could select. It depends on the I'm return. Uh, CGPDT, which are smaller, they could be also in false ceiling or plant room, but CGTXR, which are the biggest one, they are designed directly for roof and plant room. You can be install them as you prefer, or as is better for your project or your building.
Mhm,
If you have enough place to place them on roof, you could place them on roof. According to, it's important to remark that if you are going to exhaust the air, it will be more appropriate, in my opinion, to install them on roof, uh, and then exhaust directly in the air. But if you have needs of plant room, you can. It's sure that CGTXR, they cannot be installed in false ceiling, as they are really big units,
mhm,
not enormous, but a unit for an airflow of 10 cubic, uh, of 10,000, at least normal cubic meters per hour, should not be installed in false ceiling.
mhm. Yeah, it's going to be a matter of space and disponibility. If I may add something, as Gonzalo told us at the beginning of the presentation, one of the advantages of using this kind of equipment is that we can maintain the main duct clean of grease and avoid the spirit of the fire in this case. So if we had the opportunity to install it inside the building, uh, really close to the kitchen, not in the proper kitchen, but in a technical room close to the kitchen, we will have another advantage, that is we are cleaning also the duct in his way to the roof, and we are removing all the grease that could accumulate in the duct. Okay, so that could be another interesting factor to take into account in order to look for the space that probably we don't have or we have. It will depend of the project and the space we have. Okay, but it could be an interesting thing to think about, avoid the accumulation of grease in the ducts. Okay. Gonzalo, we have another question.
Yes.
If the exhaust fan system is fire rated, then so the duct leading to that should be fire rated, right?
I I'm not an expert, excuse me, sorry for this,
It it will
but
depend of the legislation of
I
every
think it
country,
makes
I
sense.
think.
I think it makes sense because it makes sense, but I cannot assure you a 100% because
We can say if it's mandatory, but make totally sense. If you
yes,
have a fire rated ventilation system, it will be full to use and not fire rate that. Okay, so make totally sense to use it.
because in this case the air would not arrive to the it makes no sense because if you do not place a fire rated duct and you place the ecology unit at the end, the air will not arrive to the ecology unit in case of fire because it will destroy the ducts and then spread
Mhm.
through all the installation. That's the reason I mentioned previously that there might be some spreading factors that we might act on them to avoid the escape of fire and fire smoke also in case of these events.
Yeah, guys, you need to forgive us. We are not really experts in the duct wall. Okay, we work with duct producers, but I think this kind of questions are more for the duct manufacturers than from us. Anyway, we are looking into this more deeply in order to answer this kind of question. I am talking about that because we have another duct related question. I'm going to read it, but the answer is the same. We need to check it. Okay. What is the recommended type of and thickness of the exhaust air ducts? It could depend probably the legislation in every country, and we will check in every case we have a proper project, okay, in order to compliance, okay. We have another suggestion, we have people asking if can we explain again the kitchen hood tool in SODECA app. Okay, as we have a little more time, if there are people that want to go out, you can. But I think it's worth it to explain again
Yeah.
the app. Okay, uh, let me, Gonzalo, just add that we are using this Spanish standard, but at the end of the day, the formulas that Gonzalo explained made totally sense if you look for another standard, a European standard or American standard. Okay, at the end of the day, we are talking about captation velocities. Okay, we need to assure enough velocity of the air through the hood in order to retain all the particles we will have, and this velocity will be higher or lower depending on the type of cooking we are doing. Okay, And again, we need to take into account the number of phases we have exposed into the air, because at the end of the day, we will induce, okay, more uh, total flow with the surrounded air. So the most parts of the hood are together with the air, the bigger will be the total flow we need. Okay. So
Yes.
Gonzalo, if you want, you could do another example with
Yes, of course.
the tool. Mhm,
I would like to remark that all legislation that they work with the 0.25 meter per second in airspeed in the kitchen hood. So this this tool also work with this 0.25, which is
mhm.
used in diverse legislation.
In most of
Yes.
them. Mhm,
So uh, you have to consider three dimension. First, the length of the kitchen hood, which means from which side to the other side, how long is the kitchen.
mhm.
If we consider 3
Yeah.
meter, I'm going to change at
Sorry, Gonzalo, normally we need to take this into account according to also the design of the proper hood, okay? You are designing the hood normally regarding the amount of electrical equipment or cooking equipment you will have. So you need to design the hood in order to cover all the work area, okay? And once you have designed the hood, you can design the extraction ventilation, okay?
that's it.
Mhm,
So I, as you can see in the previous example that we made, we have a minimum flow rate of 3,600. Okay. Uh, I want you to appreciate how this value is going to change if we increase or change dimensions. For example, if we go from 2 to 4 meters, this value get increase.
double.
M is the depth of kitchen hood. That is the length from where the chef would be placed to the end of the fire. Most part of times, but there might be an island and a kitchen cooking island. Uh, we have a wall behind the kitchen hood, and that would be the length from the kitchen person to the final area.
Yeah,
In this case,
normally, Gonzalo, it is possible. There are so many regulations that recommend to have 15 centimeters more than the area of the kitchen works. Okay, 15 more because of this induced air you will have normally. So probably it's you need to take into account the space you will have with the electronic devices and the cooking
yes.
devices, plus 15 centimeters more per each part of the kitchen hood. Okay.
So if you consider, for example, 1.5 meters, this value will also increase. This height is the value that is it cannot be as big as you want, because if you remember, in legislation they said that kitchen hood should be placed at a maximum height of 2 meters, and if kitchen preparation area is a normal area regarding people height, this value will rarely increase or go after 1 meter. Because if you think that the table in which you are cooking is 1.2 meters, so you should consider zero point 0.8 up to the kitchen hood. Okay? And
Sorry, Gonzalo. Because of we have more question related with the app, I am
okay,
uh, I am explaining to you in order to take advantage and to solve some question related. Okay. We have another question. If we can change the velocity, for example, from 0.25 meter per second to 0.35. It is not possible in this moment, but we are working to introduce new possibilities in this tool. At the end of the day, it's not a very difficult calculation. Okay, so if you want to change this, you only need to take into account that in our tool, we are taking into account 0.25 meter per second. Okay.
Shall I continue, or there is another
Yeah,
question
yeah.
here?
No,
Okay.
the other question is if we manufacture supply stainless steel kitchen hoods, we are manufacturing only the ventilation solutions. Okay,
Yes.
we don't manufacture the kitchen hoods or any other accessories related with the ventilation system. Okay, just the ventilation solution. In this case, the fan with the electrostatic filtration. Okay.
Yes, and last example that I want to mention, in this case we can change from electric to gas stove, but which makes a huge impact is the number of open faces. Because the number of open faces is the direction that the air can go and to escape from the kitchen hood. And as we want to make sure that all the air from the cooking area, from the cooking preparation area and the cooking, yes, the fires, is going through the kitchen exhaust, from the is going through the kitchen hood. Uh, if we move from one to two open faces is, for example, if we place the kitchen hood in a corner that we have free space on my left side, for example, and on my place. Uh, but for example, if we have, there will be always a minimum one open faces. If you have placed the kitchen hood with wall in both of your sides and in front of you, it will be always one open face at least in the air in the place where the chef is cooking. But if we go to three open sides in which we have the cooking area just behind the wall, just behind, and free space on both sides, the minimum rate it's increased significantly because air can escape through many different directions. And if we want to make sure that no air from the kitchen area is escaping through to other places, we have to make sure with this minimum flow rate that we are making sure that all the air is going through the kitchen hood exhaust.
Yeah, another interesting thing regarding the tool, Gonzalo, is that you can see just near to the recommended airflow rate, we will have the recommendation for the diameter of the duct. And this is
Yes.
very important because we need to bear in mind that the bigger is the total flow, the bigger we need the duct in order to reduce the noise, the vibrations, and this is a very common mistake in the designing of the or in the design of the kitchens that we will need to take into account. Okay, and as you can see, we recommend this. I don't remember, but I think is for a minimum velocity of 10 meter per second, something like that. Okay, so this is just the recommendation for assure that we are not having problems with noise, with vibrations, and these kind of things. Okay. We have another questions. Okay, so we are reaching the end of the time we have for this presentation, and I am going to read it to you. Okay, in filter units, electrostatic filters are not consumables, right? What about first stage filters and activated carbon filters? Should they be replaced often?
Um, Activate. Okay. Uh, Let me go again
Mhm.
to this picture. Okay. And I'm going to put in full screen. As you can see in the CGTXR, this would be the electrostatic filter, and yes, they don't need to be replaced. But this previous stage, which is a G2 metallic filter, is washable. So all the big particles that are going to be retained here, they can be removed. You can open laterals, side open. In this case, you can just wash them, and you don't need to replace them. Uh, in case of clogging, you shall replace the activated carbon filter because this filter cannot be washed, and once the carbon has reached its maximum capacity of retention, it will not retain more odors,
Mhm.
extra odors. So you just have to change and to replace activated carbon filters.
Yeah, the rest of all are washable, or you can maintain it in order to continue using it. And the activated carbon, it will depend of the use you have in the kitchen hood. Okay, the recommendation could be from 1 year to 2 years, every 2 years, 1 year change. Okay. So, Gonzalo, I think we don't have any more questions. Thank you so much for your participation in this Q&A time, because I think is the one of the good things about these micro learnings. If there are any other questions that we miss, because it could happen, please send your question to Gonzalo Villa. You have the email right down, and we can answer in shortly. Okay. That's all from our part. Thank you so much for being here. It's been a pleasure. We are stopping the micro learning program until we return in September, okay? Because it's summertime here in Spain. So thank you so much for your attendance in this uh, 4 micro learning we had in the first 6 months of the year, and we are coming back in September with the ones related with smoke control, pressurization system, carpet ventilation, ventilation with dampers. So I recommend you to stay tuned in order to don't miss these new sessions we will have starting in September. Okay. Thank you so much for your attention. Thank you so much, Gonzalo, for the nice presentation, and see you soon. Okay.
Thanks. Have a nice day.